So today we're starting our next unit, which deals with exponential functions and logarithms. We're going to start by learning the characteristics of exponential functions in the form of their graphs. There are two versions of exponential functions. If you look over here on our wall of functions, you can see the exponential growth function. It goes up to the right, and your exponential decay function goes down to the right. Okay? So we're going to start by looking at the similarities and just the basic characteristics of these two types of exponential functions. So you've got your growth, and you've got your decay. We're going to focus on what we're going to use as our parent growth and decay functions. So the parent growth function is going to be f of x equals 2 to the x parent decay function is going to be f of x equals 1/2 to the x, and I'll let you finish copying this. You've got a growth function, you've got a decay function. Growth is going to go up to the right. Decay is going to go down to the right. I want you to notice some special features about growth and special features about decay.
Growth going up to the right?
First of all, a growth function is going to have a base greater than 1. Base greater than 1. So is 2 greater than 1?
Yes.
Yes. Is 1 greater than 1? No, 1 is 1. Okay. So it's got to be greater than 1. So 1.1 would be the base of a growth function. 1.0008 growth function. All right. A decay function is going to have a base that is between 0 and 1. B stands for base, by the way. So the base is greater than 0, but it's less than 1. Notice I'm not including any negatives right now. If we have a negative out front, that's going to result in the reflection, but I'm not worried about that yet. Now, what is another characteristic of the parent growth and decay functions? Notice that there is a horizontal line that this curve approaches but never touches. What do we call a line that you approach and never touch? Asymptote. So for both the parent growth and the parent decay, you have an asymptote, a horizontal. Let me do that again. Let's see here. Okay. You have a horizontal asymptote, y equals 0, and again, horizontal asymptote, y equals 0. So for every exponential function, whether it be growth or decay, you're going to have a horizontal asymptote. Now, it may not always be y equals 0. It's only y equals 0. It's not only... It's y equals 0 when you're dealing with your parent, or if you don't shift it vertically at all. Okay, now you can shift your graph horizontally and still have y equals 0 as the asymptote. But if you shift it vertically, the asymptote is obviously going to change. Now, another special feature about the parent growth and decay functions is that there is a point 1 unit above the asymptote on the y-axis, so it will be your y-intercept, that we're going to call the shift point. Now, another teacher may not call it the shift point. I call it the shift point because this is the point that we're going to use to do our sketches. Now, I call it the shift point because when we are graphing an exponential function without using a table, we're going to need to know how to get some points without doing the table. Now, here's what I told the last class, and here's what I would tell any class. Any decent math student should be able, hold on just a second. So the reason that I call it the shift point is because this is the point that we're going to use in order to do our sketches. Now, you can always do a table. When I say a table, I'm talking about an XY table. In other words, you would choose some X values. Okay, you might choose these values. And you would plug those values into the function to get your Y values, and then you can graph the line, the curve. But if I use a table, guys, I'm not really learning very much about the characteristics, the special characteristics of that type of function. You can always use a table to graph a function. Great, wonderful. But I want you to learn the characteristics of that function so that you can look at that function, you can look at that graph, and you can match it, maybe, to the correct function. Or you can look at the function and match it to its graph without having to do a table. Because there are certain special features that we will look at that are going to help us do this. All right, so we've got our growth, we've got our decay. Now, I want to take a look at some other things that you need to be able to recognize when it comes to identifying growth and decay and all this kind of stuff. And then we're going to watch a video, and then we're going to do some practice. All right, so if I were to give you some functions, f of x equals 8 to the x, f of x equals 1/3 to the x, f of x equals 0.089 to the x. Could you tell me if these are growth or decay? Yeah, you should be able to by looking at the base. It's an exponential function because the exponent is in the exponent. I said that wrong. The variable is in the exponent. The base tells us what type of exponential function it is. So what is this first one?
Growth.
It's growth. With a G for growth. What is the second one?
Decay.
What is the third one?
Growth.
Decay. 0.089 is less than 1. All right. Now, there are some other aspects of these functions that we need. Notice how sometimes I use y equals and sometimes I use f of x equals. You need to know that they mean the same thing. All right, so let's take a look at this. All right. What is that plus 3 going to do to this parent function? It shifts what direction? Look over here at our wall of shifts, our wall of transformation. Vertical shift. If I add or subtract a number past the function, this is the parent right here, it's going to cause it to go up or down. So this one's going to cause it to do what?
Up 3.
All right, up 3. Now, what does that mean? It means that if my asymptote was the horizontal x-axis to start with, the plus 3 is going to tell it to do what? Go up 3. So my asymptote goes up 3 units. And what you would do when you graph that is you'd use a dotted line. Okay? Now, I still would have my shift point that is 1 unit above the asymptote on the y-axis. So it would be right here. Now, we need to be able to graph another point so we can have a good idea of how this graph looks. So what I do is I look at the number that's in front. Now, there's no number in front for this problem, but there really is. It's a 1. We're going to treat that 1, and you can look at it over here on our wall of functions. Notice the A. That 1 is the A value. We're going to treat this value like a slope. We're going to treat it like slope. So what is 1 as slope? Up 1, right 1. So I'm going to go up 1, right 1, and put a point. Now, I have to know what type of function this is, whether it's growth or decay, before I can draw my curve. Some people see those two points and they say, oh, that's a line. No, it's not. This is an exponential function. So it's going to do what? Up to the right. When you graph these things, make sure your graph does not cross the asymptote. Now, if your little arrowhead touches it, who cares? But if you draw it like this, I'm going to count off, because that tells me you don't know what you're doing. It tells me you have no idea what an asymptote is and what the graph is supposed to look like. You can't have an exponential function that looks like that. It can't touch the asymptote. It can't go through it. So that would be wrong. All right, if you had something like this, or on this one, if it was like that. Okay, that will be -1. There are 4 parts to every exponential graph that we do. 2 points, the asymptote, and the curve. You would be shocked at the number of people that graph it wrong. They do everything right. They get their points right. They get everything right. Get their points. And then they graph it like this. All right? Or they graph it like this and they cross the asymptote. Guys, come on. All right? That's why you have to know what it's supposed to look like, whether it's growth or decay, but it's always over there. It's always on the wall. All right, let's do another problem where we would have some other features. Let's say we have a 1/2 here times 1/2 to the x plus 2 minus 3. All right, all of these features are your transformations, basically. We're going to shift the shift point. Now, what does this shift tell me to do? Left 2. What does this shift tell me to do? Down 3. I'm going to write that out. You don't have to write that every time, but I might ask you to write it. I might say, what are the transformations? All right. Now, we've also got this value out front that represents the slope. We think of it as the slope, but we think of it as something else too, and I'm going to tell you that in just a minute. It has a double meaning. It has a double use. All right, so here we go. The first thing we do, number one thing, and you can write this down, and that is you graph the asymptote. We're going to write that down again somewhere else, but we're going to graph the asymptote. The second thing that you're going to do is you're going to graph the shift point. Graph the shift point. The third thing you're going to do is use the A value to graph point 2. Because you're going to have 2 points on these graphs. And the fourth thing you do is draw your curve.
That -3 goes with it, right?
Hold on. Yeah, -3 goes with it. So finish copy. Okay, so like I was just saying, the slope, what we're calling the slope, is not actually a slope. We're using it like a slope. But an exponential function has an average rate of change. Rate of change means slope. It's an average thing because it's not consistent. It's not constant. Whereas a line would have a constant rate of change. It is always the same. It's always the same slope. Now, we're going to use it like a slope, but it's not technically slope. All right, so we look at our function. It has a base of 1/2, which means it's a decay function. You've got to know that. You need to know that the graph does this. Okay? So we know it does that. Second of all, we need to graph our, when it comes to the graph, we need to draw our asymptote. So our asymptote is going to be down 3 units. So from the x-axis, go down 3 and draw a dotted line on your sketch. Now understand, this is a sketch. It's not perfect. But the asymptote needs to be perfect. Okay? The next thing is we graph our shift point. Well, the shift point we know is going to be left 2 and down 3 from where it normally is, except for I've got this 1/2 out front. It's a factor that's changing where my shift point is just a tad. So here's the thing. We will always have a shift point in a parent function that is 1 unit above the asymptote. So don't actually draw it, but just put your pencil on it. All right, so right there. Now, that shift point is going to be shifted to the left how many units? 2 units. So I'm still not going to draw it. Oops. Still not going to draw it. See there? It's right there. It's invisible. All right. Now, because there's a 1/2 out front, I have to multiply 1 by 1/2. What do I get when I multiply 1 by 1/2?
0.5.
0.5. So instead of being 1 unit above, it's going to be 0.5 above. Okay? Now, that's my first point. Now, that might have seemed a little tricky. We're going to do a lot more of these. So it's going to work its way out. I promise you. You'll figure it out. It's not complicated. All right. The next thing we do is graph our second point. We're going to use A to do that. So 1/2. What does that mean in terms of slope? Up 1 over 2. Now look, this is in the middle. So up 1, whoops. Thanks. It's amazing. Up 1 would mean I'm going to go to the middle of this one and then to the right 2, right? However, if I go to the right 2, what kind of graph is that going to be?
Growth.
It's going to be growth.
So
So I need to go to the left. Needs to be right here. Now, this is why you have to know what a decay function looks like, because if I don't, I'm not going to graph the correct function using the characteristics and the features and the skills that I've learned. So then, once I've got those 2 points, draw the curve. Make sure you draw it as neatly as you can so that it does not cross the asymptote. Okay? Now, there you go. That wasn't that complicated. We're going to do another one here in just a second. Okay? Come on, baby. Come on.
Get it right.
All right. Let's do another one. But before we do that one, let's confirm that we did this right. All right. So first of all, let's find the coordinates of these points. So let's do the one we graphed first, the shift point. All right. It has a -2 and a -2.5 for its coordinates. So let's plug in -2x. What do I get when I plug in -2? 0. 1/2 to the 0 is 1, because any number to the 0 is 1, right?
Yeah.
1 times 1/2 is what?
1.5. No.
0.5, right? 0.5 minus 3 is what? -2.5. Isn't that where this point is? -2, -2.5? They work. All right, now let's plug in the coordinates for this one. We plug in x of -4. So -4 plus 2 is what? -2. If -2 is my exponent, that means I have to take the base, reflect it, and change the sign. That's the rules of negative exponents. So 1/2 reciprocal would be 2. 2 squared is 4. 4 times 1/2 is 2. 2 minus 3 is, isn't that where that is? It's supposed to be. Well, it's not perfect, but anyway.
Yeah.
All right. So, actually, it should be in the half. Let me see here. Let me see what I did wrong.